So how do you do with on the homework with integration by parts? But how'd you do? You keep that.
Okay.
All right, yeah, let me do 2 of them. Got one? That you want to do?
Yeah.
Okay. Join me. 1 second, so I just want to take attendance. Greenberg, is he here?
No, Sister's Way.
Sisters. And Moshe? And Hannah? Not here. Okey doke. And everybody else. So sending it off to wherever it goes. Your data has been sent. And your mama. Always data. I'm gonna shut this little critter down. Say goodnight. Okay, go.
ln of x squared.
So is it x
The
squared?
whole thing is squared.
ln squared. Okay, please don't talk. If you're not interested in it, then don't pay attention. But don't talk. Thank you. So we don't know what this is. And obvious from the lesson that this is an integration by parts question, yeah? By the way, I don't know if that's on because it's got a black screen.
Yeah, no, it's fine.
As long as the green light is.
I don't see, you see green.
Yeah, good.
So in this one, it's so obvious what U is and VV is, because it's only 2 quantities. 2 quantities. Eeny and meeny. And one of them, for this one, for example, it has to be something. What does it have to be?
Yeah.
Otherwise, you're not going to be able to integrate both sides. Leaving you with U is this. So the choice in this one is given. There's not a choice. So du is the derivative, and it is stuff squared from long ago. The derivative of stuff squared is? So that would be 2 ln x times
dx.
U. Just enough room. If dv is dx, then v must be x. So let's go to our recipe. It is uv, eeny meeny, that would be x, ln of x quantity squared, minus the integral of v du. Now when you're writing this du, you notice it's a nice friendly little 1 over x here, yeah? So let me write that. That was 2 ln of x, 1 over x dx. Clearly the x's here divide out. Unfortunately, you're left with something that's still unintegrable, but better. It's not an ln squared, it's an ln. Do it again. U this time is, it could, by the way, be 2. You can attach the 2 to either one. Which one do you want to take?
I just took it out.
Yeah, that's even a better idea. So let's make it minus 2 times. So then dv would be,
Yes.
and therefore du would be,
1 over x.
thank you, and v would be, so I'm not going to put the integral, that was wrong. It's 2 times the recipe, which is
U times Excellent.
x ln x minus the integral of
Du. So X over 1 over X.
X over x.
X.
And so it's going to work now. So it's going to be this guy minus 2 of these guys minus
Plus
plus x plus a c. And that's it.
1 plus 2.
Plus 2x.
Plus 2x, sorry. Yeah, plus c, yes.
Next question.
Go.
Integral of the inverse cosine of 2x dx.
2 what?
2x and then dx.
So again, it's the same idea. I know now, I've memorized how to find the derivative of inverse cosine or whatever, but not its integral. So I have to do this by parts, and just like the last one, it's obvious. You don't have a choice here. The dv has to be
Yeah.
And the v and the u therefore has to be what's
Inverse
left.
cosine.
So maybe some room here. So du, the inverse is derivative inverse cosine of stuff. Memorize this is
-1.
over
Square root of 1 minus square stuff. 4x.
yeah, so it is 2x quantity squared or 4x squared
Times 2.
times 2 dx.
Okay.
And the v then is,
X.
let's see where this leads to, going through the recipe. uv x inverse cosine x minus the integral of v du.
Cosine 2x.
No, it's
Cosine.
Inverse
Cosine of
cosine
2x.
What I do? Oh, 2x. Thank you for the correction. So again, v du, which makes it, it is minus, so I'm going to change this to a plus. 2x over the square root of 1 minus 4x squared dx. So this 2 is in the numerator, this x from the v is in the numerator. We there? So now what?
factor 2.
You substitution.
You sure is.
Why does factor out 2?
You don't have to.
Yeah, that's what we did.
It won't make a difference either way. So,
It's
U substitution.
yes, standard regular old, because why is it happy?
Because it has an X in
Easy
it.
stuff.
That's right. So for this u, you got an x dx, you're good. Yeah, there'll be an extra issue there,
Sure.
because the u is gonna have a minus 8x, and you only have an x, so it'll be minus 1/8 of.
Yeah.
Who am I answering this for? Ruth, did you get that, bud?
Okay, yeah.
So it's gonna, minus 1/8 of, which would make it minus 1/4, because there's a 2 there, of du over the square root of u. That's really what we're gonna be left with. Because the u is 1 minus 4x squared. And that's just u to the minus a half. Integrate u to the half times 2. Plug back in u and you got it. I'm not gonna finish where I started yesterday. Are there more questions, just so I know? Yes, okay, I'm gonna try to get through this as quickly as possible and then get to your question. We actually started the lesson already. It's called Integration by Powers of Trig Functions. And if you remember, we did cosine, we did maybe cosine squared or sine squared or cosine to the fourth, yes? So when it's even powers of sine or cosine, what did we do? Or what would you do if it's an even power?
We
Yes.
substitute using the cosine, the double angle formula.
Yes. Whichever form for sine or for cosine. If it's an odd, let me go into this now. If it's an odd power, it's different. For example, let's say it was cosine to the third of x. Yes. Now again, for it to be a happy integral, it would have to have what next to it?
Sine.
It's not there. So it's not happy. So we're going to change its form a little bit, and it's going to become happy. That's the thing. Yes.
So you're gonna change it to cosine squared x times cosine x, and then the
1
cosine.
second. Please don't say it. I think you're exactly on target. Anyone see what he's thinking, or think what he's thinking? What you could do now and make it happy?
Yes.
So this is where all that trick comes in. You gotta just know. Eric?
So switch cosine squared of x to 1 plus cosine 2x over 2.
Yeah. Because that's not gonna make it happy. You have a cosine 2x, you have a cosine 1x. That's not happy. I must say that's worser.
Worse.
I don't know if it's worsest, but it's worser. Max?
Replace with cosine 2a plus 1 over 2.
That's just what you said, and it's just as bad.
Just as worse, sir.
Worserest. Should be honest.
1 minus sine squared of x.
So if this didn't pop into your brain, you have a trig deficiency. They take vitamin E, rub it on your temples.
Can you treat?
Another parentheses.
Picky, picky, picky. This should have been obvious to you. I said to make it happy, and it's putting in the question for you signs with a cosine. That makes it happy. Sine 2x or cosine 2x with a cosine doesn't make it happy. Sine to who cares what the power with this cosine makes it happy. And the idea that cosine squared is equal to 1 minus sine squared should just be resident in your brain forevermore. Say I got it.
Got it.
It's not something you have to rememorize. It's there. It's tattooed to your chromosomes. You got it. It's not something you're going to forget. Okay. This becomes two easy questions. Now you're integrating cosine x dx, big deal. And then you're integrating take away sine squared x cosine x, big deal. What's that second one? When you integrate minus sine squared x cosine x, I want the answer. Integrating cosine x obviously is sine x. What about the second part? Yes,
Sine cubed x over 3
I need an SIGN.
plus. Since it's minus originally.
Oh, it's minus.
Actually,
It's minus.
it's minus.
You're integrating cosine, which is sine.
You're integrating sine.
Which is
Now you're integrating.
minus cosine.
No, but it's u squared with its du. You get u to the
Yeah,
third
but
over
the
3. It
du
doesn't
is
change.
negative
The
cosine.
du is exactly cosine x,
Oh.
not the negative.
Derivative of sine is cosine.
We're there. So the same idea would be true if it was to the 5th power. If that was to the 5th power, you would just write 1 minus sine squared times that extra cosine x. That really is cosine squared squared, that's cosine to the 4th. Got the idea? So what you're doing is factoring out an one, if it's an odd power, an extra cosine you factor out, make whatever's left, even if it was, let's say it was cosine to the 9th. So you're factoring out a cosine x, you got a cosine to the, and what you're doing is saying, okay, cosine to the 8th
1 minus sine.
is like cosine squared to the,
Fourth.
and cosine squared to the 4th is like 1 minus
Sine squared x.
sine squared to the 4th. This is going to be happy. And it's going to take some, you may not be happy, but this is going to be happy. Because you're actually going to have to raise this to the 4th power and get 5 terms there, but each is going to be happy because there's going to be a cosine x there. Yeah?
That's nuts.
It's a happy ending. It'll take a little time to do. I won't give you one to such a high power. But if it's my point is if you factor out 1 from the odd power, it becomes an even power, and then you can always make a replacement for it. Because we're just talking about sines and cosines, yes.
So even if you're given like cosine to the 100
Yes, you're not going to be given
You have to
anything. You're not
distribute
going to be stopped.
100
Anything
times.
complicated. It would take you until your 24th birthday to finish that one. I don't want to do that to you.
Thank you.
You told me your husband's going to be saying, what do we have for dinner tonight? He said, still working on that question. I'm 3/4 finished. Anyway. And if it's this, sine to the 4th, cosine to the 5th, x dx. Anyone know? I'll give you a hint. It's not very different than if this wasn't even there. What's he getting at? What if it was just cosine to the 5th? So say now you know how to do that.
I know how to do that.
How do you do that?
Sine.
We just learned it today. How do you do that?
1 minus sine to the 4th.
It's sine
to the fourth
out
x
of 1
cosine
minus
x.
sine squared x to the
Square.
square times cosine x dx.
So you're factoring out one of the cosines, yeah?
Yeah.
And then you're turning the rest of the cosines into
One term.
1 minus
sine,
minus
yeah? It's gonna be happy.